do me a favor on your notes, cross off that 19th and put the 24th. You can also go ahead and write this equation down for example 1. This example, you can see that we have the variable, we have more than one variable, but it's on both sides of the equation. So this is the type of equation that we just saw in that opener, at least the last equation in the opener. So we have more than one variable, and it's on both sides of the equation. So we have a's on both sides here. All right, so we're gonna solve this just like we did in the opener. We're gonna start by circling the variables and drawing the line, and we see when we do that we have a's on both sides. Is there anything to distribute in this equation? Is there anything to distribute in this equation? No. Are there any like terms to combine here? No, there are like terms, but why can't we combine any of them?
Because they're on different sides.
Yeah, the variables, the 4a and the a are on different sides, the 9 and the negative 6 are on different sides, so we can't combine any of them. So the next thing we need to do is we need to get the a's on one side. So we talked about this in the opener. Which one of the a's should we get rid of? Should we get rid of the 4a here or the a by itself here, and why? Jared?
A by itself.
Why?
Because it's smaller.
Yeah, we want to get rid of the smaller one, and the reason we want to get rid of the smaller one is because we want to work with what kind of numbers? Positive numbers. As much as we can, we're going to try to work with positives. This doesn't guarantee that every single number that we're going to come across in this problem is going to be positive, but it's going to help us and make sure that at least the number in front of the variable is positive. Now, if there is no number in front of the a, what can I put there? There we can put a 1 there, so that's a 1a. So Jared, you said we want to get rid of this. How are we going to get rid of it?
Negative 1a.
Good, we're going to subtract 1a. All right, so to get rid of that, we're going to subtract it, and the reason we subtract it is because it is positive, right? So to get rid of a positive, we subtract. And if I subtract 1a on the right side, I have to subtract 1a on the left side. When I do that, my 1a's cancel over here, which leaves what on the right side? Jared, what does that leave on the right side?
It's negative.
All right, so that negative 6 is going to come down. The equal sign is going to stay on the line. And what do we have on the left side then? What's 4a minus 1a?
3a plus 9.
Good, the 3a, and then that plus 9 is just going to come down. And now we solve as usual, right? We get the a by itself by getting rid of the 3 and the 9. Which one should we get rid of first? Jared?
9.
How do we do that?
Negative 9.
Good, we're going to subtract 9 on both sides. The 9s on the left side are going to cancel each other out, which leaves what? Jared?
3a.
And on the right side, we have a negative 6 and a negative 9. So when we combine those, are we going to add or subtract? What is 6 plus 9? 15. And is that going to be a positive 15 or negative 15, Jared?
15. I'm positive.
It's going to be a negative. Why is it negative?
Not bad. It wasn't time.
Because when we add two negative numbers together, we get another negative number, right? Okay. And then how do we get rid of that 3, Jared?
You divide by 3.
Divide by 3. The 3's cancel each other out over here, leaving what?
A.
And on the right side, negative 15 divided by positive 3 is?
5.
You said negative 5, right, Jared?
Yeah, it is.
Okay. When we're doing these types of equations, the very first step is exactly the same as the equations we were doing last week. So when we have the variable in more than one place, it doesn't matter if they're all on the same side or if they're on different sides. The first thing we need to do is simplify each side of the equation. And what two things are we going to do to simplify each side of the equation? Levante? No, what two things do we need to do to simplify each side of the equation? Aiden? Distribute and then combine like terms. So we're going to distribute first and then we combine like terms. Now after that first step is when it's going to be a little bit different, because in the last kind of problem when all the variables were on one side, at this point the variables were in one place. But now since they're on different sides, we're still going to have the variable in two different places. So the next thing we have to do is get the variable on one side of the equation. All right, so we're going to get the variables on one side of the equation. Just like in that last example, what we did is we subtracted the 1a from both sides to get the a's all on the left side of the equation. Now, to do this, we're going to always get rid of the smaller one. And by getting rid of the smaller variable, that's going to leave us with a positive variable. You'll hear me use the term or the phrase, pick on the little guy. When we get to this step, I like to say pick on the little guy because the little variable, the smaller variable, is the one that we want to get rid of. All right, so when I say pick on the little guy, that just means that we want to get rid of the smaller variable. And then once we do that, once we get the variables all on one side, then we just solve as usual. We're going to have a two-step equation at that point, so we'll have one or two things to get rid of, and we get the variable by itself. We want to solve for b here. We'll go ahead and do this one together. I'm going to circle my b's. I see that I have b's on both sides of the equation. So the first thing I'm going to do, it actually doesn't matter that they're on both sides. The first thing I'm going to do is simplify each side. And the first thing I do to simplify each side is what? You guys all have it written in your notes right in front of you.
Simplify each.
By doing what?
Distribute.
Distribute. All right, Levante, is there anything to distribute here?
Yes.
What?
2.
Okay, we have 2 times the parentheses, so we're going to distribute that 2. What's 2 times b?
2b.
Okay, and then we have 2 times negative 5, which is
10.
negative 10. And then we have an equals 7b. Just bring that down. All right, so we distribute. Now, the next thing we're going to do is combine like terms. Do we have any like terms to combine?
Yep. No.
Well, I see some like terms. We have the 2b and the 7b. Can I combine those? Can I add them together? Why not? They're on different sides of the equal sign. If they're on different sides, you can't add them together. All right, so then the next step, step 2, says get the variables on one side of the equation. And we're going to pick on the little guy. So we have variables here, we have variables here. Which one do we want to pick on?
The little guy.
The smaller one, right? 2b is smaller than 7b, so we're going to get rid of the 2b. How do I get rid of the 2b? Subtract 2b. So we subtract 2b from both sides. And the 2b's are going to cancel each other out here, which leaves what on the left side?
Negative 10.
Negative 10. And on the right side, 7b minus 2b is 5b. All right, so the b is still not by itself. We're at the solve as usual step, so we need to get rid of what, Scott? We need to get rid of the 5, and that's a 5 times b, so what are we going to do to get rid of it? Divide by 5, and so on the right side we divide by 5. 5's cancel, leaving what?
B.
And on the left side, negative 10 divided by positive 5 is negative 2. So, just like every other problem we've done, we're going to circle the variables first. We're going to draw the line through the equal sign. And what do I need to do first then, Jared?
Distribute.
Good. We have 4 times the parentheses, so we're going to distribute. The 4 times c is
4c.
4c. And then the 4 times negative 3 is?
Negative 12.
Okay. And then on the right side, is there anything to distribute? So what do we do with all that other stuff?
Just bring down.
Okay, good. So we're going to bring down the 2c minus 6. All right. Once I distribute, then we're going to try to combine like terms. Are there any like terms to combine here? No, there's not. So we do have like terms, but all the like terms are on different sides of the equal sign, so we can't do that. So we're going to move on. The next thing we do, step 2, says get all of the variables on one side of the equation. So we're going to get rid of one of these two. Should I get rid of the 4c or the 2c, Jared?
2c.
Why?
It's split up.
Yeah, the 2c is smaller than 4c, so we're going to get rid of the 2c by subtracting 2c. Now, Jared, if I subtract 2c on the right side, I also have to subtract 2c on the left side. Now, why would I put the minus 2c here instead of putting the minus 2c, say, right here?
Because you'll be stressed.
Since these two are not like terms, we don't want to put them next to each other. So we're going to leave the negative 2c over here with the like term. All right, we're really subtracting the 2c from the entire thing. but the only part we can actually subtract it from is the like terms. All right, so Jared, when we subtract the 2c on the right side, those 2c's cancel each other out, which leaves what?
-6.
-6. And then on the left side, what's 4c minus 2c?
2c.
And what do we do with this minus 12?
Bring that.
Just bring that down. Okay, what next?
Then add
Now we're just solving as usual, right? So we need to get rid of the 2 and the 12 to get the c by itself. So which one should I get rid of first?
the drill.
And how do I get rid of the 12?
That's true.
Okay. So I add 12 on both sides. And on the left side, those 12s cancel each other out, which leaves what?
2c.
2c. And then on the right side, we have a -6 and a positive 12. So are we going to add or subtract?
Subtract.
What is 12 minus 6?
6.
And is that going to be a positive 6 or a -6? Why is it positive?
Because the drill is bigger.
Good. The 12's bigger, 12's positive, so our answer is positive. All right, one last thing.
Divide 2.
Divide by 2 to get rid of that 2. The 2's cancel each other out, leaving c equals
3.
3. I need to distribute first. Okay, what can I distribute here, Dorkel? Okay, good. So we have -4 times a parenthesis, so we're going to distribute that. What's -4 times d? What is -4 times positive 3? Okay. And then what do I do with everything else? Just bring it down. So we've got our -3d on the left side, equal sign, and a -12 on the right side. Okay, after I distribute, what do I do next? Okay, do we have any like terms that'll combine here? Yes. Which ones? Okay, so we have a -12 and a -12. Do those cancel each other out? No. So when we have a -12 and a +12, they would cancel each other out and they would be 0, right? But since they're both negative, we're not going to subtract them. We're going to, okay, we're going to add them. What is 12 plus 12? And since they're both negative, it's going to be a -24. Good. And we've got our -4d here, and we've got our -3d here. Now, this is actually kind of a tricky one. So the next step says we want to get all the variables on one side, and we want to do that by picking on the little guy. So my question is, what's littler? What's the smaller number? -3 or -4? Dorkel? So Dorkel says that -4 is a smaller number than -3. Do you guys agree with her? I do. So even though 4 is bigger than 3, she says that -4 is smaller than -3. Why? Exactly. So if you think about a number line, -4 is farther to the left than -3 is, right? Exactly. So since it's farther from 0 or it's farther to the left than the -3, it's actually a smaller number. So I want to get rid of the -4d. So the tricky part when we're getting rid of the smaller number is when we have a negative or when we're dealing with negatives, the negative number that's bigger is actually smaller. It's actually going to be the little guy that we want to get rid of. So how do we get rid of that -4d? Good. We're going to add 4d on both sides. Yeah, so these cancel each other out. We bring down our -24. And then on the left side, we have a negative and a positive, so we're going to subtract, right? What's 4 minus 3? 1d. And is that going to be a positive or a negative? Because? Good. The bigger number here is positive, so our answer is positive. Okay? Okay, good. So to get rid of this 1 here, we don't have to divide. You don't have to divide by 1. You could, but you would get the same thing, right? So 1d is the same thing as just d by itself, so we can just scratch that 1 out and box our answer. d equals -24.
I knew it.
If you had, let's say you had gotten rid of this -3d here by adding 3d. So let's say you added 3d here, and you added 3d here. You could get the same answer. You would get the same answer as long as you do everything correctly. but it would be at least one more step. It would actually be two more steps. Yeah, so we would have a negative 1d here, and we would also have the negative 24 over here. So we'd have to add 24 to both sides and then divide by negative 1. So it would be more steps that way also.